It's my first F-Class build, a 7 PRCW with help from Erik Cortina. We're going to kick it off in this video. Gavin here from UltimateReloader.com. This has been a crazy year. I was at the SHOT Show this year, and Brian from Build Hunt Explore had me go over to the WOOX booth. I took a look at their stuff, and I was like, whoa, this is absolutely amazing. Also, I've been working with Erik Cortina, collaborating on some content. We've had some podcast type stuff. He came here for the Rock Check Olympics, and I said, what would you think of me building an F-Class rifle? Well, that visit to WOOX, I've got the Titano here, and some collaboration opportunities with Erik Cortina have come together for this series. That's right. I'm going to be building an F-Class rifle. It's going to be chambered in 7 PRCW, and it's going to be based on this WOOX Titano stock, which is really cool. So we're going to waste no time and get it out of the elegant packaging. How about that? This thing is a beaut. It's walnut, which is my favorite wood, and it's just beautifully constructed. And so this is for bench rest and F-Class, very similar rifle specifications and uses. F-Class is sometimes referred to as bench rest on your belly because you're using a lot of the same equipment, you know, front rest, rear rest, and rifle platform, that kind of thing. You just happen to be shooting on your belly instead of from a bench, and obviously different rules, different game, that kind of thing. Okay, so we've got a 3-inch wide fore-end. We've got a Remington 700 footprint. This is a really interesting configuration. We've got a cheek riser, we've got the beautiful walnut, we've got an aluminum backbone here, and we've got a weight system that we can use to adapt the rifle to our particular uses. So this is WOOX Titano. This is really exciting. To go with that, I've got a custom bat VR. This is their varmint repeater, but with no bottom cut, because we don't want a bottom cut with a bench rest or F-Class rifle. It's more rigid without that cut, and we're going to single load anyhow. So this is a VR without the bottom cut. This is a Remington 700 clone. It's short action. I've used a lot of bat actions. You've seen a lot of them here on the channel. It's got an integral rail, integral lug. These are the features I'm looking for in an ultra accurate rifle. Now, what's different with this platform, if you go back and you watch my Eddie Van Halen tribute rifle build, that was a completely custom inletting with a bat model M, which has a mid-mounted separate lug. And this is cool because you could drop a Remington 700 action into this and just use it. I've got a special action here without, you know, the bottom cut. But when I did the EVH rifle, I had to, on the milling machine, do my barrel channel. I had to do the complete inlet. It was just a slab of fiberglass when I started, and I had to do a very intricate bedding job to get everything exactly how I wanted it to be. This is more turnkey, which is really cool. Okay, so what else do we have for the build? From Manson, we have a finisher reamer. This is to the specifications that Erik Cortina gave to Manson. So that is a great starting point. The chamber geometry is really critical. I've also got go and no-go gauges that were from my 6.5 PRC build, which are going to work great for 7 PRCW because it is essentially a 6.5 PRC necked up to 7mm. We've also got the EC Tuner V2. I'm going to be doing a dedicated video on that, outlining the entire process start to finish on the lathe and using it, and how that's going to factor into how we tune our ammunition. Really good stuff. Erik was kind enough to send me this Brux barrel blank. I have never used a Brux before. I know Erik Cortina works with Brux. He exclusively shoots Brux in competition. This is a straight 1.25 inches. So the Titano currently goes up to 1.2 inches. I'm going to have to do just a little bit of inletting there, opening up the barrel channel to accommodate this 1.25 inch straight barrel blank. This is going to be really, really fun. So we're going to be on the Precision Matthews TL1660, the big bad boy, and it's going to be a heck of a lot of fun. So I'm going to go and I'm going to research all of the specifics for what I need to do for this chambering job, and I'm going to show you that step by step. Well, my first 7 PRCW chambering job is done. Now, before I get into the details of that, of which there are many, I want to make a couple quick acknowledgments. First, thank you, Bruce Tom, and thank you, Gordy Gritters, for all of the things that you've taught me about the machinery, the setups, and the processes. Second, this video is brought to you in part by the Colorado School of Trades. This is a great place to go if you want to learn the hands-on machining skills, all about firearm systems, etc., that is going to position you to do work like this. They actually teach chambering at CST. We're going to be there. We're going to have some great content. Stay tuned for that. Okay, so let's get into the details. Just like with any project, the prep work is really critical. It's paramount to a good chambering job and a smooth experience getting to that desired result. So when I prepare for a chambering job, there's a few things that I'm taking a look at. First, I get the tenon print from the rifle action manufacturer. Now, Bat Machine is really good about this. They have tenon prints for all of their actions, and those prints have all of the information and details that you're going to need for your chambering job, including things like your minimum shank diameter. For the VR, which we're using here, we've got 1.2 inches minimum. I've got a 1.25 inch barrel blank, so we're good to go there. It's also going to tell you things like what the threading specification is, the acceptable thread relief, different dimensions, including reamer stick out. So all really good stuff. That combined with your SAMI diagram, right? Each SAMI specification diagram for a particular cartridge has 2 sections. You've got the ammunition on the top, you've got the chamber on the bottom. I'm focusing on the chamber diagram here, and we've got some calculations that we need to make here. First, we're going to calculate our reamer plunge. When we are done, the gauge is going to stick out a certain amount, right? And that's actually specified here on the diagram. That actual stick out is a very simple calculation based on what numbers are there. If we combine that with the breech face to shoulder dimension from the SAMI chamber diagram, we can calculate how far the reamer needs to go in from the start of the shoulder transition to the depth that we're going to ream to. And based on that, we can calculate what our pre-drill needs to be. The pre-drill is going to be about 30 thousandths under the shoulder diameter, the major part of the shoulder, the largest diameter portion of that. And the depth is going to be the reamer plunge. In other words, how far does the reamer go in starting at this shoulder transition to the depth? We're going to subtract about 150 thousandths or thereabout from that and pre-drill to that depth. Doing these calculations a couple times just to make sure is going to put you in a good position to get going on the chambering job. I'm going to write that on a print-off copy of the SAMI diagram. I've also got other calculation sheets. I like to have it right at the headstock of the lathe so that as I'm doing machining calculations and machining, I have that reference and it's right below the DRO. So I'm looking at my numbers, I'm looking at my specifications, making sure that things are agreeing and matching. Okay, so that's the prep work, right? We measure 5 times and we cut once in metalworking. So the next thing I did was a temporary muzzle threading. My pressure flush system is based on 5/8-24. And if I do enough jobs, I make adapters that go from whatever the thread specification is. For the 338 Lapua that I built, it was 3/4-24. So I have a 3/4-24 to 5/8 adapter. That way I can just do the final muzzle threading, use the adapter, and it'll hook up to the 5/8 high pressure oil fitting that I have on my pressure flush situation. This time I decided I'm just going to do a really quick 5/8 threading job. Does not need to be precise. It can be slightly undersized on the threads. I don't have to do any dialing at all. So this is a quick process. I had the cameras running the whole time, and when I stopped the camera, it was 13 minutes. So it was worth it to do that to get ready for pressure flush. Then we install the barrel extension. So I made this barrel extension from an old takeoff barrel that was already threaded 5/8 milled some flats here, and then put a female 5/8 socket on there. This is going to screw right on to the end of the barrel, and this is very helpful for long spindle lathes so that you can blow compressed air, so that you've got your high pressure oil for pressure flush chambering, and so that you can support the outside of the barrel to keep the barrel from flopping around. Okay, so that's just a part of my process. Then we get ready for chambering by doing our pre-drill. So what I'm going to do is I'm going to take the breech end of the barrel shank. I'm going to go off the OD and get it within 1/1000th of an inch, right? This is just a very rough dial so that we can remove the bulk material from the chamber, and that's the first part of it. The second part of it is so that we can get the nose of the 1/10,000th indicator into the area where it can read off of the lands and grooves so that we can do our final dial, right? So we pre-drill, we get the nose in there, we dial to 1/10,000th of an inch. 2-point right in that throat area, right in the most critical area. We're going to get right where the throat is to 1/10,000th. We're going to go about 3/4 of an inch to an inch forward, do that process, and kind of go back and forth until everything is running perfectly true. Then it's time to prepare for threading the tenon, right? These threads right here. And so I have a process now, and this is based on some tooling, VNMG inserts specifically that Bruce Tom showed me that work really, really well. I can do all this without removing the tool from the lathe, which is awesome because with manual lathes and Aloris type tool posts, the repeatability sometimes can be 1/1000th of an inch, maybe a little bit better. And if you can keep the tool on, it just saves time and it gives you that repeatability. So the first step here is to take that rough drilling that we did and use a single point boring technique with a boring bar to bore that section true, because this is going to become the surface that the reamer hits first. It's going to guide the reamer in. We want it to start nice and true. We want it to end nice and true. Then we're going to face the barrel, and I'm using this VNMG insert, and as I'm facing, I'm zeroing the Z-axis on the DRO, which will correspond to how long the tenon is that we're turning. I turn the OD to the proper specification. Usually that's a couple thousandths under the nominal diameter. So this is 1 1/16 by 18. So instead of 1.0625, we turn it to 1.060. So it's 2.5 thousandths under what would be the nominal diameter, because the peaks of the threads do not reach a sharp point. They have a very slight flat on them. As I'm turning the OD of the tenon, I'm stopping a couple thousandths short, and that's so that I can clean up the shoulder when I'm all done turning everything to length. I take a quick check before I get to the final diameter with my Meditoyo digital 1 to 2 inch OD micrometer to make sure that the DRO and the actual dimensions are in sync. Remember, because we faced and zeroed the Z-axis, now we know exactly where we are with that tenon length. After I am at the appropriate diameter for the threaded portion, I will face the shoulder to the exact length specified on the tenon print, and then I'll cut the thread relief. And I have a chart that I've made that gives me all of the dimensions for that. We're going to go to the minor diameter of our threading minus 5 to 10 thousandths of an inch. When that thread relief is cut, I go to the outside of the barrel and I cut another thread relief there. The tenon print actually shows a 45-degree angle kind of a chamfer, but I like to turn a little relief at the start. It helps to get things started, and that's not a critical mechanical interface, but you do have to have the appropriate relief for actions that specify that, right? The threading on the inside of the receiver sometimes it stops at a certain point, and you don't want to be binding up, right? You want the shoulder of the barrel to hit the front of the receiver with no exceptions. So at this point, we're ready for threading. So when it comes to precision threading on a lathe, there's some key factors of interest. First, the OD. As I mentioned, it typically is a couple thousandths. It scales proportionally what that reduction factor is based on diameter. So the OD is one of the first things that you're thinking about. The threads per inch, which you need to set on the lathe, and we'll check. The pitch diameter, which is a representation of the diameter of the threads. That's not the major or minor diameter. It's kind of like a headspace dimension. It's measured with a threading micrometer or with the over wires technique, where you put 2 wires on the top and 1 on the bottom, or reverse, and you measure with a micrometer. Because what we care about is the thread interface, not the top or the bottom of the threads. So I also take a look at my calculation for the anticipated compound infeed at 29 degrees. These are all the things that I've got in my head, and sometimes I've got written down, I've got on my own proprietary charts, that sort of thing. So the first thing I do is I set my cross slide depth stop. I've got a special depth stop that I've designed that helps that cross slide come back to 0 each time exactly, provides a bit of compression so that the cross slide is not able to move at all, and it makes that precision return to 0 really quick each time. So I'll come in at about 1/1000th of an inch at 29 degrees, take a test cut, and check our thread pitch with a pitch gauge. This is really important. Did we shift the levers correctly on the lathe? Are we going to get the right number of threads per inch? You got to check that before you get going. Then I'm going to start removing the bulk material by infeeding 5/1000th of an inch at a time at 29 degrees with the compound. I've zeroed the dial on the compound, so I know where I'm starting with. I know what my anticipated total infeed is, and I'll just start the passes, 5, then 10, then 15, then 20, and so on and so forth. Each time we do a pass, we retract the tool with the cross slide, we traverse back on our Z-axis with the saddle, we come back and hit the stop, make sure that we're right at 0 on the DRO. The specific mag-exact DRO from Precision Matthews has a resolution of 1/10,000th of an inch on the diameter. So it's a very, very precise. And I just love that, the fact that I always know exactly where I'm at. Now when I get to, say, about 2/1000ths under my anticipated compound infeed, I'll do a quick pitch measurement, the pitch diameter, with a threading micrometer. This is something that Bruce Tom specifically showed me and has been very helpful. So I'm going off of the tenon print and my calculations, and I'll say, okay, well, I've got a few thousandths of an inch to go. I've got my own trig chart. I know if I need to take a few thousandths off the diameter, what that corresponds to in terms of compound infeed. I'll make those adjustments and then cut it to the appropriate diameter. Now it's time to check with the action. So we screw the action onto the threads, and I know I don't want it tight. That's going to cause galling and is unnecessary because the threads will center up the action on the barrel. I know just how much rattle I want, and I might make one more pass if I'm not happy with that fit. But with this technique, it's very quick to come up to the appropriate diameter, and I don't have a lot of guesswork, and it's very repeatable. Okay, now the main attraction, cutting the chamber with pressure flush. Now to step back for a moment, there's 2 ways that I've shown this process. The first process is you put oil on the reamer, you put oil in the chamber, you bring the tailstock up to position, and you cut X amount. You retract the tailstock, you remove the reamer, you blow it off, you reinstall it, you repeat the process over and over. The good thing about this process is it's very simple to set up for, and you can do frequent checks very easily for run out and for headspace, that kind of thing, without kind of putting anything into a different state. The downside is there's a lot of reamer plunges. I might start with 200 thousandths of an inch and then go to 100 thousandths of an inch and then go to 20 thousandths of an inch. That's a lot of reamer removals, a lot of mess and that kind of thing. So pressure flush is a really great capability, but it does have some overhead with regard to cleaning up the machine. I've got my own custom drain pan. I have to get that all put together. There's still some mess, but when you go to cut the chamber, it's a little bit more turn and burn. So what I do is I get the machine all ready. I turn on the flow of oil and I'll do an initial cut to about a 1/2 inch or so. Now, important to note here, how am I keeping track of my overall cut depth? What I do is a technique that I learned from Bruce Tom, which is to zero your saddle, the Z-axis, and make sure that that's zeroed on the DRO. And then you have an interface between the tailstock and the saddle. For this particular machine, it was an Allen cap screw that I tightened down near where the scale hooks up. Something has to contact repeatably and solidly, and you don't want it to be your DRO scale itself. So I can bring the tailstock back into position, and if I bump the saddle a couple 10,000ths of an inch, I can return it to the 0 position and relock that down. Now I've got a tailstock DRO that's mounted to the quill of the tailstock. That gets zeroed right where this shoulder transition starts to enter the chamber, right there. So now I know what my reamer plunge is, that cut depth, and I can repeat it. So I cut about 1/2 of an inch, pull everything out, check for run out. In this particular case, running dead true. Lathe setup, great. I'm using a rigid reamer holder. I've got an entire video on this. One quick note is you're going to want to make sure that you use 2 screws, one at the front of the reamer and one at the back, so that you don't somehow impose any kind of tilt there. These have to be machined in place. What's great about it is if your tailstock is too low or too high, after you've machined this, it totally doesn't matter. Everything is centered up perfectly. Rigid tooling is better tooling, so I'm a believer in this. The one downside is reamer shanks do vary in diameter, so you might have to cut a few inserts or get a few of these Morse taper blanks to account for maybe 7/16 minus 1,000th and then 2 10,000th increments, something like that. So loving this setup. The chamber cut here went really good. We did 1/2 inch, we did 1 inch, and then I basically cut to the anticipated depth minus about 5,000th of an inch. I got my go gauge installed in the action, screwed the action on, and then measured the gap. The go gauge is now hitting the shoulder inside the chamber, so that gap will be representative of how much further we would need to cut to basically be at go gauge depth before torquing the receiver down, right? There's several things to take into account here. So what I did was I got that measurement and I cut using the cut depth indicated on the tailstock DRO to basically go plus 1.5 thousandths of an inch. So if I have a 1/2 thousandth or 1,000th crush, when I tighten the action down to its full 90 foot-pounds of torque specification, I'm at go plus just a little bit. Go plus a 1/2 thou, go plus 1 thou once everything is all tightened down. A little bit less critical with this setup because all of the brass will be fire formed. So if there's a little bit of variation, it's not like I'm taking factory ammunition or once fired brass from someone else and trying to make it work here, or multiple rifles. If I do another rifle, I'll chamber it to exactly the same depth. But I like to be where Sammy's at, plus about 1,000th of an inch, plus or minus a 1/2 thousandth. Everything will fire form and then be completely consistent from there forward. We're going to be turning the necks of the brass. We've got a bit of work to do to get everything where it needs to be for this project. Quite a bit more exacting than a typical rifle build and a typical shooting scenario. So everything went really well. With some proprietary tooling, I was able to verify that I was at that go plus 1.5 thousandth. Super happy with that. Then we do a quick polish on the chamber, chamfer the chamber entrance ever so slightly to assist with feeding, and we're done. At this point, all that's left is to crack torque on our barrel extension, remove the barrel from the lathe. I like to run a couple patches through to get everything cleaned up, to clean up the pressure flush system, and so on and so forth. So what we're going to do in the next video is we're going to flip things around. We're going to work on the muzzle end. So I'm going to part this off, and I will go through the process of machining and installing an EC tuner. This is the EC Tuner V2 that we've got right here. I'll give you complete instructions and a total walkthrough of that from start to finish. After that, we're going to be installing everything in the WOOX stock. We're going to be installing a scope, breaking things in, and then we'll see where this adventure goes with Erik Cortina and F-Class John. These are my mentors. I am new to F-Class. I want to see what I can do with this. This is going to be a ton of fun. Okay, one more plug for the Colorado School of Trades. If you want to learn this kind of stuff, if you want to be proficient with all of the background knowledge that you're going to need to position yourself and prepare yourself for this type of work, the Colorado School of Trades is worth a very in-depth look. Thanks again to Erik Cortina for supplying me with this barrel blank and being my mentor on this project. Really appreciate that and looking forward to seeing what we can do with that. Cool. Okay, so what I want to know from you is, what do you think of this build so far? Are you wanting to chamber your own rifles, or do you? Drop a comment and share your experiences. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. If you're interested in custom rifles like what we build here on the channel or gunsmithing services, you're going to want to go to rifles.ultimatereloader.com and get on the wait list. If you want to learn lucrative gunsmithing like what I show here on the channel, including building custom rifles and Cerakote plus a whole bunch more, you're going to want to check out the Colorado School of Trades, schooloftrades.edu. Thanks again for watching.